Hi again. Welcome to problem 7.10, B and D. We're going to write a balanced equation for the dissociation of each of the following strong electrolytes in water. And you want to be sure that you know how to input this into mastering. I've done a couple of these on videos, so hopefully by now you know how to enter these. But you want to be sure that you use reaction arrows and that you put the state of matter also next to the compound. Okay, so we have calcium chloride, which is a solid, okay, and it's in water. I don't believe you have to write the water on your, or input that into mastering. Strong electrolytes mean that there's 100% dissociation of the solute into ions. Okay, and so this really goes back to chapter 4. So if you have forgotten how to come up with the formal charge or the oxidation state of metals and nonmetals, you'll want to go back and look at those videos in chapter 4. Okay, so calcium is going to become calcium ion, and we know that calcium has a 2+ charge because it is a group 2 metal, and it's going to have a 2+ formal charge because it wants to lose 2 electrons to be like the nearest noble gas. So you can convince yourself of this if you look at a periodic table. Okay, and this is going to be aqueous, so we've got to be sure that you input that into mastering. Okay, aqueous means it's in water. Okay, and then we have chlorine, which is going to become chloride, and it has a -1 charge because chlorine is in group 7 and it wants to gain 1 electron to be like the nearest noble gas. Okay, but we can't forget to balance, so we have 2 chlorines, we're going to have 2 chlorides. Okay, and so this would be the balanced equation for the dissociation of calcium chloride. Okay, for D, we have iron 3 nitrate, okay, but we have to come up with that. So I just said iron 3, okay, so you have to remember where we get this from, okay. So this also goes back to really naming metals with variable charge, because I think the hardest thing for students in these problems is just for them to basically remember how to get the formal charge on the metal and the nonmetal, or the cation and the anion. Okay, and so we're going to go ahead, we'll draw what we know here. Okay, and this is a solid, so we put that next to it. So we know we're going to have iron, okay, but it's going to be dissociating into its constituent ions, so we need to place our charge there, so we'll come back and do that. And then we want to recognize that we have a polyatomic ion. Okay, so right here, this group of atoms is a polyatomic ion. Okay, and so if you look on your polyatomic ion list, which you will be given this for this test as well, we have a -1 charge. Okay, and so this is going to be aqueous, so this would also be up there in the balanced equation. Okay, but we need to place our charge on, our formal charge on the iron. Okay, so this just goes back to naming. So we've got iron, has a variable charge, so we need to find what that formal charge is. We have nitrate with a -1 charge, and we know that our overall charge has to equal 0. Okay, so once again, this is all back from chapter 4. Okay, and so we have 1 iron atom that's present in our formula, and we do not know its charge. And we have 3, so our 3 comes from there. We have 3 nitrates, and we have a -1 charge. Okay, so you can rearrange and solve for x, or you can just look at this and simply say that x is going to have to be +3 in order for the overall charge to equal 0. Okay, so we put our +3. So now we have our charges taken care of, but we need to be sure that our equation is balanced. Okay, and so we want to look here. We've got 1 iron on each side, but we have 3 nitrates if you want to look at it as a whole. Okay, and so we're going to need 3 of our nitrates. nitrate ions on the product side as well. And so once again, don't forget to insert the solid, the aqueous, the states of matter, and be sure you know how to get these charges. This concludes the video for problem 7.10.